Magic Monk. In this lesson, we're going to talk about the difference between definite and indefinite integrals. So let's start off by doing an indefinite integral, which is probably the integral that you have done a few of, and but you never understood really what it means. So that's so let's say we have y dy over dx equals 3x squared plus 5x. So this is the derivative of y. Okay, so integration is going backwards to find out what y equals. So in order to find that, we need to integrate this function. So we need to integrate it, which is the opposite of differentiation with respect to x. So then we integrate it and we go 3x cubed over 3 plus 5x squared over 2 plus c. And if we simplify it a little bit, you'll be able to see that 3 divided by 3 is 1, so it's x cubed plus 5x squared over 2 plus c. So now if we try and graph that, okay, what happens is we won't be able to find out exactly what c is. So c is what makes this an indefinite integral, because c can be anything. C is unknown. So because we don't know what c is, this is not definite. So that's why we call it indefinite. Now, if you try to graph this equation, so if we turn on the calculator and I go to graph and I clear some of these things that I've graphed before. So if I type in x cubed over x cubed plus 5x squared over 2 and then I just graph it, so I get some sort of equation here, but I don't know what c is, so I haven't put it in there. But right now c is equal to 0. Okay, so let's put down another one where we have x cubed plus 5x squared divided by 2 plus let's say c is 3. So the top one, obviously c is 0, and the bottom one c is 3. Let's do another one where c is, let's say c is negative 1. 5x squared over 2. Let's say c is negative 1. Okay, if we draw a graph, you'll see 3 different lines. Now, what do you notice about these 3 different lines is they all have the same gradient. These 3 equations, these 3 lines are all integrals of this equation because they all have the same gradient at every single coordinate for x. Okay, the y coordinate has obviously changed because we put a different amount of plus c on the end, but the x coordinate and their gradients are the same. So let's say I want to find the gradient. Let's say I want to go second calc and I go to number 6, which is finding the gradient. And you can choose any of these lines. Okay, up and down will change the lines. So let's say I go to the line at the top. You'll see that when x is negative, when x is 0.4, let's just make it 0.5 to make it easier. When x is 0.5, the gradient is 3.25. Now, if I go to the middle line, and I find out when x is 0.5, What is the gradient? It's 3.25 again. So these three lines have the same gradient no matter where x is. Okay, so these are called indefinite integrals. Indefinite because we don't know which line it is because they all have the same gradient. In order for us to find out which exact line it is, you will need to get additional information in the question. So the question might say, when c is equal to, when x is equal to 1, y is equal to 1. So if this is included in the question, then we can find out which exact line it is. So then we can go y equals x cubed plus 5x squared over 2 plus c, and then you can keep going to find out what c is. So when y is equal to 1, x is equal to 1 plus c, so c is equal to 1, let's just keep going for a second. 1 equals, 1 cubed is 1 plus 5 times 1 divided by 2 is just 5 over 2 plus c. So c is therefore equal to 1 minus 5 over 2, which is equal to, let's put that in the calculator, 1 minus 1 minus 5 over 2, and the answer is negative 2.5. And now we can find out that this line y is equal to x cubed plus 5x squared over 2 plus minus 2.5, and then this is the exact line. Okay, so that's indefinite integral. Let's talk about what definite integral is. Now, definite integral is when you integrate something. So let's say I integrate the same thing. Let's say I integrate 3x squared plus 5x. But instead of finding out the exact line, what you do is, in a definite integral, there is a boundary for the domain. So let's say I specify the domain as from x is 0 to x is 3. X is 0 to x is 3. So then what you do is you get the integral of this, so that's 3x cubed over 3 plus 5x squared over 2, and then you don't need to write plus c again, because I will show you the reason. Okay, because if you substitute 3 in first, you go 3 times 3 cubed over 3. So I'm not going to write 3 over 3 because that's just 1. So it's just 3 cubed, right? Because 3 divided by 3 is just 1. So it's substituting 3 into x. So then it's 3 cubed plus 5 times 3 squared over 2. Now you're going to get the answer for that first. So it's 3 cubed plus 5 times 3 squared over 2. And the answer is 49.5. And then you're going to take it away from substituting 0 in there. So 0 cubed plus 5 times 0 squared over 2. Anyway, this is just 0. So minus 0 equals 49.5 minus 0 is just 49.5. Okay, so what does the definite integral tell us? Firstly, let me explain why you don't put plus c. Because if you want to put plus c, you can put it in here, plus c, plus c, plus c, and then you're just taking c away from each other, because you'll go c minus c here, c minus c, which then turns out to be nothing anyway. So that's why you don't need plus c when you're doing a definite integral. Okay, secondly, what does the definite integral tell us? It tells us the difference between the y values. So when x is 3 and when x is 0, what's the difference in the y value? Difference in y value. So that's why if you were going to graph these equations, okay, remember how we had 3 of these lines. Let's look at the difference in y value between when x is 0 and x is 3. It's going to be the same in all 3 lines. So if I graph it and I find out what x is equal to, so let's just do trace. Okay, so let's go to the line at the bottom. Which is that one there. When x is 0, y is -1. So x, when x is 0, when x is 0, there are 3 equations. Okay, so we got y is -1, and then we got y is 0, and we have y is 3. Okay, and then let's go to when x is equal to 3. What are the y values? Okay, when x is equal to 3, the y values are 50. Alright, let's go to the one at the bottom. The one at the bottom is this one. We got y1. We got 48.5, and then the one in the middle is 49.5, and then the one at the top is 52.5. Now if you look at the difference between these y values, okay, if you went 48.5, which is y1, minus -1, what do you get? You get 48.5 plus 1, which is 49.5. If you went 49.5 minus 0, it's still 49.5. If you went 52.5 minus 3, it's still 49.5. So that's why this is called a definite integral, because you get a numerical answer and there is no constant at the end. This is the exact answer. The definite integral has an exact answer. There is no uncertainty in the definite integral. It's telling you the equation that differentiates into this function has a difference in y value between x is 0 and x is 3. This number is the difference in the y value in the integral. Okay, I hope this helps you a little bit to understand the difference between indefinite and definite integrals. Thanks for watching, guys. See you next time.